Hey everyone, welcome back with quality control, quality assurance for chemical analysis. In the previous lecture, I said that quality of results equivalent to its accuracy. And to ensure the quality of results, to improve the quality of results, you should have high accuracy. And to have this high accuracy, you should try to reduce the errors for all steps of your preparation, from the beginning, from sampling up to giving the result to the customer, up to final result. And to ensure that, you should have quality control program, including some steps you should follow with every run to ensure the performance of your work, and at the end you will have high accuracy for your results. Quality control program is very important for any method to ensure the performance of the method, the performance of the instrument, and the competency of the analyst every run. So you have some lab operations should be controlled. Lab operations should be controlled every run to ensure that performance, and to ensure at the end that you will get accurate results or valid results within acceptable range. So lab operations to ensure that data generated by the lab are of known accuracy within acceptable limit to some extent quantitative degree of probability. These lab operations including what? Including the instrument, the method, and the standard and reference materials used, pure reagents that you use or chemicals, and also personnel. Before quality control procedures, you should optimize the instrument and the method to be fit for your purpose, fit to analyze the target analytes required and provide you with the valid results within acceptable range. An instrument should be selected to be fit for purpose based on the budget of the lab, and also very important to include the target analytes specification limit or maximum limit. As example, if the maximum limit or specification limit for your target analytes is very low, in very low concentration, so in this case you need a very high sensitive instrument to be able to get the lowest concentration required. If you don't have very high sensitive instrument, you cannot analyze this very low concentration. But in case of very high specification limit, as example in ppm, in this case you don't need to have very high sensitive instrument, but you should have an instrument which is fit for your purpose. As example, you don't need LC mass, but you can analyze using HPLC, or GC mass, but you can analyze using GC. So after selection of the instrument which is fit for your purpose, you will select the method which is fit for the instrument and fit to analyze these target analytes. If you search in publications, you will find method to analyze the same target analytes by using HPLC, and another method to analyze the same target analytes by using LC mass and other instrument, and so on. So you will select the method which is fit for the instrument that you have selected. Method should be also fit for your purpose. After you will select the method, you should evaluate the performance of this method. Even you will verify or validate. Verify in case of reference method, and validate in case of method developed inside the lab developed method or in-house method. So that's very important at the beginning, before preparing to the quality control procedures, preparing quality control program inside your lab, to select the instrument and the method which is fit for purpose. Then you need to have the quality control program or procedures that will ensure the performance of both of them every run or for long time scale. And very important, you should know that quality control not to eliminate or minimize the errors. This job is in the development stage. In the development stage for any method, you should ensure that your method is valid to analyze the target analytes and they provide you with the valid results within acceptable range. So you should try to eliminate or minimize the errors to be within this acceptable range. And after that, you will evaluate the performance of this method to ensure that. Then you will prepare the quality control procedures to evaluate or estimate the errors. and you ensure that you are still within acceptable range. All processes are subject to errors. Quality control not to eliminate or minimize the errors, but to estimate or evaluate them. You need to know that there is no errors high that affect the accuracy of the results, but during development stage you should try to minimize the errors to achieve the accepted accuracy. So this is the expected value, and you analyze many or replicate, and you did replicate analysis for this expected value, and all of them should be during development stage should be within acceptable range. This is the acceptable range, and these are your results during development stage or validation or verification of your method. If you find that results out of this acceptable range, so you need to change this method. This method is not fit for purpose. And then we have quality assurance. Quality assurance is the ability of the lab to prove the appropriate quality of data provided to the customer. So what is the difference between quality assurance and the quality control? Both of them have the same objective, to prove the appropriate quality of data provided to the customer. But quality control is one step. Quality control procedures should be implemented for all methods, and this is one step inside the quality assurance program. And quality control and the quality assurance, both of them inside the quality management system. So quality assurance, the ability of the lab to prove the appropriate quality of data provided to the customer. Lab shall assure that quality control procedures, first point, quality control procedures being implemented for any method inside the lab. As example, we have pH meter used to measure the pH, and before measuring the pH for samples, you should have quality control procedure for this equipment. You should calibrate and verify this equipment to ensure the performance of the equipment before measuring the pH for samples. Calibration and verification, and if there is any maintenance required to be followed to maintain the equipment. And quality assurance including the procedure, how to calibrate, when do you need to calibrate, do you need internal or external calibration, and how to run or measure the samples using this equipment, and also what calibration you need, external or internal, buffers used, what are the buffers you need to use. So you need to know, you need to prepare specific SOP or general procedure, including how to calibrate this equipment. You should cover the range of pH required. As example, if you analyze water samples, pH will be in the range of 7. So you need to be before and after. You will select 3 levels of pH, 3 buffers of pH, as example 4, 7 and 10, and you will measure all of them before measuring of any sample. Then how you will verify using 7 buffer pH buffer 7. Then there is acceptance limit for all of them, and how to ensure that this calibration is accepted or not accepted, that will be written inside the procedure. And also what calibration you need to make internal or external calibration. For this you need to have specific buffers, what are buffers required to be used or to be measured. And also you will prepare a specific form to record the result for this calibration and verification, to write the performance of this equipment before measuring of any sample. So under quality assurance program, lab shall assure that first point, quality control procedures are being implemented for any method inside the lab. And second point, samples analyzed. Samples analyzed shall be representative to ensure that the reported results reflect the sample as received from the field. Very important point. Sampling is very important process now. According to ISO IEC 17025 2017 edition, if the lab is responsible for sampling, they shall apply all requirements of this document on sampling as on analysis. But if not responsible for sampling, they don't need to apply all of these requirements on sampling, but they shall ensure that the sample analyzed are representative. The sample analyzed are representative, so they will ensure that the reported results reflect the samples as received from the field, so there is no problem inside the lab. Once you receive the sample inside the lab, your sample shall be homogenized and shall be handled in a very good way and shall be stored well. Then you will ensure that the sample is same like you received from the customer. So to ensure that the reported results reflect samples as received from the field, so sample analyzed shall be representative, and you will prepare, if you are responsible for sampling, you will prepare sampling plan, sampling procedure, sample handling and storage. If you are responsible or not responsible, you will apply this sample handling and storage. You should handling, there should not be any mix-up, any contamination between samples. And also storage is very important. Samples should be properly preserved prior to analysis. So handling and storage is very important for any lab, if you are responsible for sampling or not. But sampling plan and the procedure, if you are responsible for sampling, you shall prepare this. So once you receive the sample from the customer, you shall preserve it well in a specific temperature until analysis. And you should follow up this temperature using thermometer or data logger to ensure that the sample is representative. After that, sample preparation or extraction method until reporting the result. You will apply some quality control procedures that will be explained inshallah in details after that. And also you should facilitate traceability of the analytical results. All reported results shall be traceable. Now, if the customer has a complaint for any result, he will come to the lab and ask you that I have problem with this result. I am not sure that this result is right or not. So you want to make reverse traceability. You want to go back from the time or the date that you analyzed this sample and to know everything about this sample to ensure the validity of the result for this sample. So reported results shall be traceable. You should have some data reported to include the date of analysis, the analyst who ran this sample, the method used for analysis and the instrument used for analysis, the status or performance of the analytical system, the instrument used at the time of analysis. All data required should be documented or recorded every day for samples, for every sequence, to have traceability for the results. And that called reverse traceability, because you will go back from the date of analysis to know everything about all information about this sample to explain to the customer. So to ensure at the end, you need to ensure the validity of results for the customer. And also under quality assurance program, you have precautions. You have some precautions taken to protect the data generated from loss or damage, to ensure the integrity of data. And all of these points under quality assurance program. So quality control procedures is one point under quality assurance program, and both of them under the quality management system. So for quality control procedures, you need to get a valid results within acceptable limit. And also in quality assurance program, you need to prove the appropriate quality of data. Both of them same, and you need to maintain a good quality assurance program, including quality control procedures, and including samples shall be representative, including some precautions taken to protect the data against loss, and also you should have traceability for the data generated. All of them will be under quality assurance program, and quality assurance, quality control, both of them under the quality management system. That was the difference only between quality control and the quality assurance. Thank you, and see you in the next lecture.